industry, because this data everybody would have seen that, but then it's always good to show as a first slide and then move forward. And then talk a little bit about the trends in the downstream semiconductor industry, because that's the topic of the day. And then talk a little bit about, finally, what are the innovations that are shaping the semiconductor industry. So first, a little bit of data. Second, talk about the downstream in semiconductor industry. And third, with the innovations. It's fine? Anything else we can take it as a Q&A. Next slide, please. So, before I talk, I need to talk a little bit about my company and the company that I work for. It's just 10 seconds. We are one of the largest electronic manufacturing services company with a large infrastructure of manufacturing facilities. We are a $3.4 billion in valuation. These keep changes depending upon the stock prices of the day. 220 million revenue, large set of customers, and large set of employees. Out of all this good things, there's another good thing on the right corner of it, that we've been part of the moon mission and to ISRO, and that stuff had 4 packages of which came out of Keynes. So that's a little bit of good stuff that happened out of Keynes, among all the other businesses that we do. So that was worth mentioning. Next slide. Okay, so this market as an overview, I'm sure everybody is aware of it. The OSAT market is pegged at 40 billion in 2023. The estimated is to go 7.5%, 8% CAGR and go up to 2030 close to 68.2 billion. Look at a few market highlights. This is all data, everybody's aware of it. Our colleagues and friends from Southeast Asia, which is Taiwan, Malaysia, Korea, and the likes of Philippines, and have a larger share there. Top 10 OSAT companies account to 80% of the market. Taiwan accounts to 41% of that market. And then, this market is growing on a yearly percentage growth of 14%. So this is some statistics that we thought we'll put it and then move forward. Next slide. Okay, now we talked about the statistics. We talked about what the growth is. Let's look at where is the growth coming from. What kind of top 5 companies? Because now when we embark on putting an OSAT as a manufacturing plant in India, let's look at what the top 5 guys have done. Where are they moving? What's in it for us? If they take the entire share, what's in it for us? Look at the top 5, nothing to beat. ASC, Amcor, JSET, and all of them take a major chunk of 50 to 60%. But the point is to look at some of the verbose over there. Look at what Amcor is doing, look at what ASC is doing, and look at what Carson is doing. A few points on this. These guys are looking at now advanced technologies, which means that they would leave space for the wire-bond technologies, a little bit of the BGA. So that is where we can come in, that's number one. Look at the applications that they will go about. Mobile will still continue, communication will still continue, but what's in it for India? We see a lot of automobile stuff happening in. What we can do in automobile is what I'm going to show in the next few slides. So this is about the OSAT market and the OSAT companies and the market that they operate on. Third slide. I will tend to do this a little fast because there are a couple of slides I want to show and it's only 8-9 minutes. So if Professor Rao is not here, he keeps telling about it. The technology that we are getting into, if you look at MCM, SIP, and all of that is all at 30 years old or 35 years old. But having said that, you would have heard some of us saying that, we will do wire-bond technology and slowly move into the BGAs and flip-chip BGAs, is rightfully said because there is market over there. That's number one. Number two, as we move forward, look at where the world is going after. The top 5 OSAT will obviously move into, they have moved into 2.5, 3D, the die-to-die, and then get into silicon photonics. So that's where the trend is moving after. And some of the English that I spoke about, people are looking at 2.5, 3D, people are looking at die-to-die, and people are looking at heterogeneous kind of packages, right? We are not yet there, but I'm sure we will pick some of the sweet spots looking at the application in the market and pick some of the technologies to do our OSAT. Next slide. Now, in the 3 kinds of packages, one I will say less complex, second I would say mid-complex, and third I would say advanced complexity, right? Look at how the market growth is going. All are single digit. The wire bond, the QFN SOTTO, the flip chip, BGA and flip chip BGA are all growing at 3 to 6.5%. The one that is growing at us is the advanced packages, which is nothing but the co-package optics, and 2.5 3D is growing at 18%. Nevertheless, the base is smaller. You know, the base is 4.6 to 16.8, whereas others is a much bigger base, which gives us a belief that, you know, if we do some of these stuff in India, we have to be cost competitive. We have to look at what volume we can do. We can look at what application we will do. And some of those are highlighted in the verbose over there. Next slide. So we looked at the OSAT worldwide market. We looked at the companies in that market. We looked at the kind of technology. Now let's look at the application. You know, where are these kind of applications going? What kind of a design starts are happening? What kind of a products are being done in the overall segment? And what kind of advanced packaging, right? So these are the various segments. And now look at advanced packaging, which we looked at the highest growth rate, but a smaller base is going in this fashion. The HPC, the consumer, network, mobile, auto, and industry, right? So these are the various markets that are going to pick up. I don't know my friends in Siemens here or not. If you look at one company which I want to talk about is Nepes Corporation, which is a South Korean company. You know, they put in technologies and processes in place from a thermal simulation and stuff like that, which is another area. You know, in India we should look at design and stuff like that. Next slides. Now, you know, I thought I will, since the topic was trends and what kind of innovation that is happening, I thought I'll put one slide, not to look at, you know, the top chart, look at the key drivers. The drivers for 2.5 3D or interposer or chiplet are these three applications. One is primarily the big data or the computing, right? So that would, and when you have a big computing platforms to be made or big chipsets to be made, nevertheless, you know, you need to have a faster throughput, a turnaround time, and stuff like that, right? And lower latency. And that's where the silicon photonics comes into being. And then, you know, a few others. And then we looked at, you know, the players that have moved into space as ASC, Armcore, and hence they are vacating the wire bond and BGA and stuff. Next slide. Now, getting to co-package optics, what are the market drivers in this? First, look at what is the estimated. Right now, it is close to 15 million, but it is pegged to grow to 49 million. And the drivers are nothing but, you know, the 3-4 companies takes the cake, and the investment that they are doing, which is Amazon, Microsoft, and Google, whole lot of investment that they are doing. So we as an organization, when we are planning to set up OSAT as a business, we looked at all the three packages, and we have invested in a company who's working on the co-package optics. And that's the technology that we want to bring into India from a design standpoint and from process standpoint, and net effect put a system out of it. So which means that, you know, few of us who are putting an OSAT plan should look at some of these statistics and data when we are looking at what kind of a package and what kind of a market. Next. Now, how is this co-package optics or the silicon photonics affecting the Asia Pacific as a market? Now, with the 5G rollout, with the 6G in advent, I'm sure a lot of the silicon photonics or the co-package optics will go there. And a few of those companies like, you know, the Broadcom, the Intels, the Qualcomm is all looking at how chips could be made smarter and how could co-package optics be brought into being. Next. Okay. I'm not going to read into the various partnerships and the investments that is happening all over the world. We have read about CHIPS Act. We have read about European Act. We know what our own country, ISM, is doing. We know Southeast Asia, Malaysia is putting in money and stuff like that. So, you know, various countries are making sure that they become self-sufficient and hence don't depend upon, you know, countries and stuff. While 7-8 years back, the narrative was different. 7-8 years back, we all said that let's focus on what we are doing good. And at that point in time, predominantly, we were good designers. We still are very good designers. So it was told that we should focus on the chip design as an activity because we are second to none at this point in time. But slowly, you know, geopolitical conditions and all that have changed, which is making us to invest into manufacturing. And you can see that a whole lot of companies and countries are looking at, and a whole lot of partnerships that are happening in making sure, you know, one way or the other, they become self-sufficient. Next slide. Coming to India back again, these are the data which is taken from the IESA, and you could see automation, automobile, mobile as a segment are big growth areas for semiconductor chips. Next. Next. Yes. Now, taking a leaf out of it, there are three markets that we want to focus. One is the smartphone market, second is the wearable market, and the third is the India laptop. And there are many topics that we can talk about. Let's look at the PLI benefit. Let's look at the product-linked initiative which the government of India is looking at, so that to enable the laptop manufacturing in India. Otherwise, you keep paying, you're ensuring that there's no manufacturing happening in India. Same is the case with smartphone. We have all heard about the Apple manufacturing and stuff like that. And slowly, I'm sure the smart wearable would also be done in India. We as a company are looking at the AR/VR glasses, the entire product to be done in our Hyderabad factory. So net, we believe that this volume would increase, and more of chips would be used, which are OSAT done in India. Next slide. Now, this leads us to another question. Why do we need to do, if we are an EMS company, why should we do PCB manufacturing? Why should we do OSAT? We believe that, with the supply chain resilience, in the previous session, we spoke a lot about it, with the turnaround time that we have worked with our customers, the way we have been closer to our customers makes us to believe that, we do these two things, PCB and OSAT would net bring the import duty, and thus we enable to do manufacturing this and then consume these in our EMS, and thus give a better product, plus lower down the cost of the end product. And that's why we believe that doing an OSAT and a bare board PCB is very important. Next slide. To all this now, let me link it to, we spoke about packaging, we spoke about the market, we spoke about the products that we want to do, we looked at what market we should get into. We believe that, once we do a package and a semiconductor chips, affecting that to a system would be very important. Because if we don't do systems in India, if we don't design and manufacture system in India, where would the chips come from? So that's important. These are three areas that we're looking at. BLDC controllers, EV two-wheelers, and technology. Next slide, I think almost, yes. And this is again an example of, I'm showing how the prices would be brought down. If you are doing certain packages which go into power devices, modules, and then two-wheelers. And then if you're an EMS company, this all net affects in the price of the two-wheeler down. Next slide. So that was a quick discussion about which leads to the panel. We looked at Keynes, we looked at the global OSAT as a market, we looked at the journey everybody went through, we looked at what kind of a package we should look at, three kinds of package we looked at. We looked at the innovation, we looked at the partnership that is being driven, and how is Keynes helping in the EMS and electronics. Thank you.
Thank you very much, sir. And do we have one question for sir? Then it's welcome. And if it's two, no. Okay.
Yeah, that's what I showed. So we will. So I think we'll take it offline, but then to quickly let you know, we are doing a HDI grade and a large infrastructure. And that we saw that, the HDI and a multi-layer kind of a PCB would help some of the mobile space, and that's the area that we want to get into. Thank you.
Thank you so much. And sir, you can stay behind. We would request Dr. Madhvi Joshi, Joint Director, GBRC, to kindly felicitate sir. Thank you, Mr. Panikkar, for that enlightening presentation on the latest trends and innovations. And it's truly fascinating to see where the industry is heading. We now move to the panel discussion, and give us just 2 moments for the stage to get set. We have a panel discussion titled Expanding Opportunities in Semiconductor Downstream Sectors. This discussion will be moderated by Mr. Sudhir Nayak, co-founder of E-Infochips Limited and ISA, head for the Midwest region. Allow me to introduce our distinguished panelists, Mr. Nilesh Desai, Director at SAC, Mr. Sunil Parekh, Zydus Kerala Healthcare Limited, Mr. Upendra Patel, CEO at Glide Technology Private Limited, Mr. Praveen Bangotra, Head BD at TEPL, Mr. Amit Saroj, GM Procurement at Hero Motors, Mr. Jerry Ignis, CEO at CG Semi. Welcome, gentlemen, on board. Request Mr. Sudhir Nayak, as a moderator, to kindly step up, and also the panelist. The most obedient audience of the day, what are you supposed to do? Thank you so much. Ladies and gentlemen, you can clap louder and give a great round of applause for the moderator and panelists. Thank you.
4:10. Okay. Okay, first and foremost, good afternoon. I think Raghu has done a good job of showing slides and waking you up. So my job is much easier. I would like to thank Government of Gujarat, Department of Science and Technology, and GACM for providing this opportunity with renowned people from the industries. We are talking about the downstream sectors. And I think Raghu has talked about OSAT, another part of it. But there's a major applications in the downstream that is on the application side, actually. So as you know, few years back, we rarely talk about chips, though it has created the latest world which we live in. All the nations globally have diverted their fate in harnessing the power of computing. And which nations, those nations who have garnered those power, our companies have become larger than the countries. For example, NVIDIA, they are 3.3 trillion US dollar. They can buy out Russia. They can buy out Brazil. Their market cap is so big, actually. If you look at Apple, whatever we do here in the terms of revenue, I think the R&D spend of Apple is around $25 billion per annum. So this is what it takes when you talk about semiconductor. I will just give you the little bit idea before we go into the asking questions to the panelist, that the world market for semiconductor today is in the range of 545 billion to 550 billion US dollar. Against that, the consumer electronics market globally is 5.4 trillion US dollar. Only consumer electronics. IT spend is also in the 5.3 trillion region. So I think there is a much larger scope in the application and in the downstream. We are all focused right now on the chip manufacturing and OSAT and other areas, but I think there is a much, much bigger role to play India as a country. If you want to become a 5 trillion economy, I think we have no options but to harness the power of end product which is enabled by semiconductor. Hence my discussion with all these friends will be on how to garnish this potential. Coming back to India, I think just let us connect the whole thing. Today if you look at it, India is at inflection point for semiconductor. And today our consumption in the range is of $45 billion. out of which only 8% of 45 billion is sourced from India. This is likely to go to $110 billion, only semiconductor, I am not talking about the products, is going to reach around $110 billion US dollar. At least we have to garnish more than 20% of that actually. And even if 20% of that is 20 billion US dollar. So it's a huge market for semiconductor itself. Against that, India's end product requirement is going to go to 540 billion US dollar. And right now we are importing most of the things actually. Keeping this as a background, I think we are very much thankful to Tata and Micron and CG Power so that they started this initiative that is giving us an opportunity to meet, talk about these things. Otherwise, India will remain only a design house, fabulous design companies and not the manufacturing company. Time has come that these people have taken the challenge to make India, and especially I am from Gujarat, so Gujarat as a epic center of semiconductor. I think it is left to the people of Gujarat and industrialists how much they want to harness the opportunity. Otherwise, what will happen, you will create the lunch and somebody will come and eat the lunch. So that choice is yours. With that, I would like to have first question to Sri Dr. Nilesh Desai, because SAC has been designing and manufacturing chips from very early days. They have a small fab as well. I was fortunate to visit them. And we would like to know from Nilesh Desai a few things about what are their plans, future plans for Gaganyaan and beyond that actually. I will start with that question first. So we will have one question each first and then we will go to the second round. Nilesh bhai, can you throw some light on your SAC future plan beyond Gaganyaan? You all may be knowing his contribution and SAC contribution Ahmedabad in all our the spacecraft which has gone. All lander cameras, everything, payloads, all are designed here in Ahmedabad under his leadership. Navik chip has been, I think here Pinakin also is there. Yeah, so I think we have designed those chips, manufactured HCL and Tower. They have a clean room, they have all manufacturing facility within Ahmedabad, just across the road.
As all of us know, India has missed out the microelectronics revolution. So now it is the time to catch up, especially with these newer, at least deep submicron technologies. So as far as this, what Dr. Sudhir Bhai was asking me about ISRO's plans, as far as we are concerned here at Space Application Center, which is one of the second largest center of Indian Space Research Organization situated here in Ahmedabad. So we have what we call a RF microwave related MMIC foundry small setup here at our Ahmedabad center. And as far as other microelectronic designs are concerned, we do the design and get it fabricated either at SCL Chandigarh, which had been earlier part of ISRO and now again it has moved back to METI, and or otherwise at other foundries in mostly in Taiwan or South Korea. So that is the way we used to operate. But now with the plans to set up these industry foundries near Ahmedabad, we see a very great opportunity for, especially for various ISRO programs. And all of you are well aware of course, Chandrayaan and Mangalyaan and all that has made us famous, but that is only the around 15 to 20% of activities which ISRO does. The other 75-80% of activities is related to satellite communication, navigation, remote sensing, where I see a very huge potential of usage of various semiconductor chips related to that. Of course, we had been using discrete chips, which have again been imported. The emphasis being more on space qualified or mil qualified devices, which we had been using till now. But now all of you know that internationally also the trend is getting reversed, and there is going to be a huge demand for commercial off-the-shelf or military off-the-shelf devices. So there I see a very lot of potential, especially for our Gaganyaan as well as other planetary mission program, where emphasis is on miniaturization, because we cannot afford very big circuits or big subsystem there, because we have to go so far with the amount of fuel and other things which are built into that. So miniaturization and low power devices, that is going to be the norms as far as the planetary exploration or space exploration is concerned. And related to, so I see a huge potential of there using, making use of the designs which ISRO makes and get it now fabricated at the foundries which are going to come up. Of course, SCL has been one of our captive foundries, but apart from that, I see a lot of potential of using these foundries which are coming up in Ahmedabad. Apart from that, all of you may be well aware that, again, with this Starlink and OneWeb type of satellite communication broadband systems, again now the trend in the established space sector also is towards using a low-cost satellites. So earlier when the satellite cost used to be around 300 to 500 crores, now the trend is towards using a 5 to 10 crore satellite, so that you launch them in a large number as constellation or formations. So again, the trend there is towards miniaturization and using low-cost devices. So again, there also I see a very huge potential of using all these devices which we design here and get it fabricated again through the foundries which will be available now in India itself. So all in all, I see a huge potential, and of course all of you know that today India's share in global space market is only 2%. And with to speed up that and to make it at least 5 or 10% only, Modi Sahab has opened up the space sector since last couple of years with the setting up of InSpace in Ahmedabad as a headquarter. So again, all in all, I see a very huge potential for semiconductor industry which is coming up in Ahmedabad.
So thank you, Nilesh Bhai, and big applause to Nilesh Bhai for creating this. Just small questions as a compliment. How are you going to help this manpower to train them for space requirement as well as for the semiconductor requirement?
So again, we have, all of you may be aware that in this Vibrant 2024 itself, we had a MOU with Gujarat Knowledge Society, Space Application Center, ISRO, as well as InSpace. So we have a three-way MOU, and under this, we are now setting up, Gujarat government is setting up 2 centers of excellence, one in Ahmedabad and another in Rajkot. So that will be mainly utilized for skill development. Basically, our emphasis is to create the ecosystem, starting with design, then fabrication, skill development related to various fabrication and other assembly aspects, as well as finally the verification aspects. So all in all, ISRO is going to work as a mentor for all these activities. And I see a lot of potential, not only for us, but also for the other ancillary industries which are going to be set up under that.
Thank you, Nilesh Bhai. Before I go to Mr. Sunil Parekh, I would like to, I have 2 standard phrases with me, and I would like to just broadcast it to you people. In last few years, there is not a single chip in the globe where there is no Indian inside. All the chips which are manufactured and designed have an Indian within the chips. That is one thing. In one of the Vibrant Gujarat, Sri Ratan Tata said that those who don't invest in Gujarat are fools. And when they invested in Nano, they say, I'm no longer a fool. I just modified that phrase, and I said that those who don't invest resources in terms of time, education, or money in semiconductor are going to regret. Because this is 10 to 15 years wave. If we don't catch on right now, I think we are going to be miss the bus again like IT. So Gujarat especially has missed the IT bus to embark on bullet train. So this is a bullet train for us. Please embark on it actually. I'm coming to you, sir. How will this investment in Gujarat of 12 to 15 billion today committed, how it is going to help actually, the state?
So globally, Sudhir, you mentioned that the global market is about $1,000 billion, $1 trillion by 2030. And AI. The next $300 billion is in communication. The first is computing, the second is communication, and another $300 billion is in industrial and auto electronics. So these are the 3 that account for $950 billion out of the 1,000 that is projected by 2030. Now that industrial automation, which is $300 billion projection, 50% of it is auto electronics and 50% is all other industrials together. Now Gujarat is a manufacturing state, Sudhir Bhai. And the major sectors that we have here are chemicals and petrochemicals. There is pharma, there is food, gems and jewelry, ports, logistics, textiles, engineering, financial services. We have financial services at Gift City. We have equipment manufacturing, EVs. It's the house of modern hospitals and record keeping and patient engagement. These are the major sectors, other than a few others like ceramics and are also there, where we produce more than 30 to 40% of India's total requirement from this state alone. Now, each and every one of these sectors of industry is growing over 10% now. So the market for semiconductors as a manufacturing state will continue to grow because we also have a very large share in equipment manufacturing, which then puts the embedded technology inside to a consumer of machinery, for example, like in pharma. The second big area, and just to another figure that I'd like to leave you with, the industrial output of India is about $1.5 trillion. And Gujarat accounts 1/5 of it, which is $300 billion. So for all manufacturers of chips, this is the place where the consumers of all these chips are going to be residing here. The things that are driving the manufacturing sector in this area are basically IoT, AI, machine learning, and lots of other technologies which are applicable in research and development now, in marketing, in sales, in legal and jurisprudence. The industry is going through a manufacturing and service industries are going through a complete digitization transformation. And these are the drivers for creating global competitiveness. The second area for business in Gujarat, as we heard in the other two sessions, and much of this what we have discussed are covered, is the supply of chemicals and gases, where Gujarat remains one of the largest states in this sector. And we have an opportunity to now create that 99.99995 decimal place purity. But let me assure you, Sudhir bhai, Gujarat is not new to high precision manufacture of chemicals. Pharmaceutical is no different in terms of its purity requirements as compared to the semiconductor industries. The clean room in pharma industry, where I come from, also has 95.99999% purity. So for a chemical industry to change from what they are doing for the pharma industry and adapt, whether it is gases, minerals or metals, it's not a new technology. So our friend from PSMC was saying that it took Korea 20 years to do it. I can confidently tell you this entire thing will be happening in 5 years. And Gujarat, in one of the earlier presentations showed, is already supplying 35% of all chemicals and gases to the entire semiconductor industry today from this very state. The third area of business, I think, which is likely to grow, an area that you are very familiar with, is DLI, the design-led incentive which is now available. India is a leader in design, and a lot of this will take place in Gujarat also, given the fact that it has the base. And the last big area that I think chip manufacturers have in Gujarat is to offer solutions in the area of sustainability for all these large investments that are coming in. We have CG Power here at the end here. He will require a lot of green services and a lot of support in management of utilities which are all green, waste disposal and other allied areas, and training developments. These are several areas where I think the state is really going to reap the benefit of this investment in supporting the development and investment and in the utilization of the products that are likely to come out.
Thank you very much for throwing a lot of lights on I think tons of opportunities. It all once again depends on us, how much we want to garnish actually. I would like to move on to, because we are restricted on time, so I think I have to jeep the things. So I will move on to now Praveenji. Thank you so much to Tata Group for coming up with the investment of $9 billion actually. And I think it is the starting point of the epic area which is going to flourish in time to come. In coming 5 years, I think our GDP of Gujarat is going to be double or triple actually with this activity. So Praveenji, my first question is, this is the first plant of manufacturing in the country.
Yeah.
So what kind of challenges you envisage, and
Yeah.
how are you going to mitigate those risks in
Right.
terms of resources, in terms of logistics
Yeah.
and supply chain?
Yeah. Thank you, Naik Sahab. Thank you, my co-panelists and my colleagues. Basically, I'll give a little background and then come back to what you have asked
Be
me.
brief,
We as a nation today, as on date, is #1 position for our digital payments. We are number 2 in the market size of smartwatches, smartphones. We have an internet base of about 800 million internet users, each one of them almost gulping 20 gigabytes of data every month. Yet, what is required for all this, the soil for us, all this, the driving force for all this is the semiconductors, and that is what we don't have. We are kind of working on some borrowed soil from other countries, some of South Asian countries, and we have achieved all this. Now, your question included with the Tatas and Micron and CGs and Dholera coming up with this semiconductor ecosystem. Thankfully, it has been realized that we have to have our indigenous soil on which all these applications have to grow. You will vouch for this, that the semiconductor, since you have been associated with IESA, you have been a driving force behind that. We talk of, by 2030, semiconductor market size of 110 billion, and yet we, as you rightly said, almost 95% of it we are still importing. With the organizations like Tata Electronics, which is setting up a plant of the size of 50,000 wafer starts per minute, and providing a technology starting with 28 nanometer to 110 nanometers, we virtually cover almost all the complete spectrum of semiconductor technology. And then last week only, there's been an agreement signed with Synopsys for the design, so it gives an additional strength. What I see in the coming days is that we have a region in Dholera which represents the greater region of China. We were creating an alternative to what it is. But then it is just not that you have the buildings and you have the infrastructure that does it. What happens during this infrastructure, out of my experience with Semiconductor Complex Limited for 30 years, is because there will be a lot of technologists, designers, engineers, vendors, innovators who would flock around there. And if we have provided them the right kind of environment, what starts happening is a lot of innovation, lot of product improvement, lot of new thinkings. All this put together, when I say the backstream market development, the backstream market development starts happening in 3 ways out of this. The one is the kind of new businesses that happen because of the semiconductor. Fabless design house is, of course, number 1. Sir also mentioned that. Fabless design house has been recognized by the government, and as on date, we have around 50 fabless design houses, 30 of them being covered by the Government of India under the DLSI scheme. In this country today, you name a global R&D house or design house, they have a presence here. It is the Indian engineers who are almost designing 30,000 semiconductor designs every year and sending them abroad. There are so many IPs which have been generated by the Indian brains. As Sir rightly said, there is an Indian in every semiconductor chip. So all these IPs that have been generated were actually the product of India, done by Indians, what we do not have the ownership. This is where the gap has been. Now these fabless design houses, I expect that they will come out in large numbers, because now you have a fab to anchor upon. Earlier, these fabless design houses would be depending on some fab outside, which would what has been called the Make in India program, the Viksit Bharat program. This will drive that. And apart from the fabless design houses, the one, As Raghu said that PCB manufacturing is yet another one area. Now PCB manufacturing has been kind of traditional PCB manufacturing, but now we are talking of flexible, hard, rigid and hard, HDI PCBs, and PCBs itself is a very, very complex phenomenon now. There is expected that a lot of PCB houses should come up. The semiconductors would generate this new market of PCBs. There is the skill development of the people. Maybe the universities would have to come forward to train the engineers in the area of semiconductors. Another areas, of course, which has a lot of potential to come up is EMS, the design houses, the ODMS design houses. These are some of the new areas that come up. There is yet another side of this where you have your existing products. The semiconductor would have the potential to change that product into a better product. Maybe you have a consumer PCB using 10 devices. Now you could integrate it into a single device. So what do you have in you? You have, you can stop me in case. My problem is if I start speaking, then somebody has to stop me. Yeah, including my wife. No, not here. So that's why I'm speaking.
He's scared, you're at distance, he's scared.
Yeah. She's sitting in Chandigarh, but still scared of her. So, so what I was saying is that you see, you get out of 10 devices that you are using. This experiment, actually, I'm talking out of my sheer experience because we did this for Eureka Forbes. Eureka Forbes approached us with their PCB. We converted their electronics into a single device, put some music into this, put some extra functions into this, and suddenly realized that by paying, of course, one-time development charges, their product price had drastically gone down with added features on this. And while in SCL, we have, Eureka 4 for their electronic needs was completely dependent on us. So it was a new product, which there is a lot of potential of new product. And then in this country, where if I look at the defense, we have to have devices which could work from Kargil to run of Kutch, from minus 55 degrees to plus 65 degrees. So we could design in-house devices, which are the need of the avionics and defense. Since the devices are reduced in size, in weight, they have better reliability. The devices could be, that is actually the need of the space program, as the CISR has been telling, and the defense and medical equipment where we want everything to be portable, bearable. So all those systems could be reduced. Yeah, and give me the last minute before I start. Yeah, and third, of course, is all those suppliers to the fab itself. If each fab would need maybe 300 people working, 300 different suppliers working in the area of chemicals, the service providers or the testing engineers and this. Thank you for the first round and listening to me.
Yeah. Thank you so much. I think we have so much of thing to listen from all experts available over here. It is a rare opportunity, but time is a constraint, so we will move forward. I will just add one paisa on what he has said. In the morning session, those who were present, I think Dr. Ranjit Thakur said that all this manufacturing is going to be having AI driven. Recently, I was with the Global Foundry, and you will be surprised to know that they have 1,000 engineers sitting in Bangalore, and they are managing all processes in the 6 plants globally. So AI is going everywhere, where you cannot think of even. It's a great opportunity even for all software people, those who are here, and those who want to make a career over there. Now I will move on to, I think we know the market is there. I think it is well established. That is why the plants are coming up. And I think we have expertise. Wherever we have gap, we are going to produce. I would like to listen from Jerry on what was the strategy adopted the Philippines OSAT companies to develop downstream market in the country. I think that will give you some idea because everybody's talking about market and process, but I think how did you mitigate that?
Basically, I have written my response to the topic that I will be discussing. And I would like to mention it, then after that, I will throw away my answer to the question and share to you that the activities...
Can you please bring this?
Yeah, okay. So I have outlined 4 strategies, and I'll just mention it. Number 1 is the market penetration strategies. Number 2 is the industry advocacy and support. Number 3 is the investment in research and development. And number 4 is the talent development and skill enhancement. So I decided not to explain each and every item because for the information of the listener, I came from the Philippines. And I was a former president and country manager of one of the leading outsourcing assembly and test in the world. So if I will share with you how the OSAT improved significantly in the Philippines, I will just share some of the major items so that there will be some discussion related to this one. I was hired recently by the CG Semi Private Limited approximately 2 months ago. And the main reason is that I'll be setting up CG Semi in relation to the OSAT requirements of the business. So since my experience is approximately 25 years in the OSAT, I work in the IDM for 2 major companies. Then I work in the OSAT, one of the leading OSAT companies in the world. So the way this leading company handles the improvement or the volume in the downstream market, the strategy of the leading company in the world is basically they have 6 countries site in the world. You mentioned it. You have Taiwan, you have China, you have Korea, and many more. And I was part of the team where we grew the business in the Philippines. So what are those things that we have done? So the way we handle it is that, by the way, I'll be bringing those methodologies, the business model, here in India, CG Semi. And for the Philippines, the way we do it is that in the headquarters, there is what you call the big ones. All the new product lines are being done in the main headquarters. So they have a R&D department there where they spend a lot of money, spend a lot of time of engineers. Then as soon as this particular product become matured, they will bring it to many countries of the company, right? So if I'm in the Philippines, you are in Taiwan. And the way we do this is that we have done what you call proximity. So like, for example, if I'm producing SOIC, I'll be producing the legacy products. The cost model of that particular product must be aligned to the cost model of the country.
So sorry to interrupt you, Jerry. I think we can take up further in the next question.
Yeah,
then you can go into the actual subject.
Okay, so what we're saying now is that we have done a lot of business model in relation to the leading semiconductor OSAT in the world. So I'll be bringing that here in India. So the time is a constraint because only 3 minutes. So total of about 6 minutes. So if I will explain it to some of my vendors, in fact, some of them I know because I used to work in the Philippines. So I will stop after this one. Then on the second round, I still have another 3 minutes of discussion related to how the business is
Thanks,
being
Jerry.
done. Okay, thank you, sir. Thank you.
If we have 6 minutes second round, I don't think we will have second round.
Okay.
So I think I will go to Upendra. Upendra has been on the design side. So Upendra, with all of your experience in the embedded product design throughout your career, it will be good to know the people that how to identify what kind of chip to be manufactured in this kind of fab and what kind of a chip to be packaged. And if there are some database and there are some numbers on that actually, or like RISC-V, can we do that? So please enlighten the people on this. What kind of chip you should design and get it manufactured?
Hello. Yeah, so I'll just share my experience of my 2 visits to China that will lead to what chips we should design. 15 years back, I had gone for surveillance market, and 8 out of 10 products were using the same chip from Huawei. So that is something like which we are working on, particularly the healthcare and wearable segment, where most of the chips and sensors are imported today, and that's why anybody who tries to design products in India becomes very expensive. So that's an area where if we use RISC-V based microcontrollers with wireless and sensor integration, that can be a huge potential. Most of the people are talking about like 3 nanometers, 5 nanometers and all. What I'm talking about is a mass consumer market or healthcare where it can become affordable to buy healthcare devices. So maybe companies can focus on chip designs around that, and then it can scale up. And second more important area which I came to know during my China visit last month, where we were exploring partners for electric vehicle chargers business. And there we are comparing the cost of, like, if I want to make the same product in India versus at what price they are making in China. So one of the realization was the power semiconductors, which we are never focusing on. But if we look at today's market, the electric vehicles, the charging infrastructures, the solar power infrastructure, all of that, they use high power devices, which in India still nobody is manufacturing, at least I know of. Most of the time when we think of, we look at big players. So that's another market people can think of. How do we bring those into India? So then our import bill, right, export whatever increase we are doing, it is offset by our semiconductor imports. So if we can focus on these segments and bring down the import bill.
Thanks, Upendra. To the point in time. Thank you so much. I will go to Amit now. As you know, right now, all of us in our daily life, minimum we cross to 500 to 700 chips, every individual. If you don't have non-EV vehicle, and if you have EV vehicle, then it is more than 2,000 chips. Some of the latest Tesla car using more than 3,000 chips in a single car. Having said that, automotive is one of the biggest market for semiconductor, especially. I would like to, Amit, since he comes from Hero Corp, current status of India adoption of semiconductor, and what do you see 5, 10, 15 years hence actually? Because people are designing the car which are going to come after 12 years. So what's your take on that? Because you are coming from Hero Corp and you are from the sourcing side, so I think your input will be very, very valuable. Thank you.
Thank you, Nagji. So quickly, I would like to introduce myself. I am from Hero MotoCorp, and the company which is into two-wheeler manufacturing, and world number 1 for last 20 years by volume. So I am working in procurement department as general manager, sourcing and development. So as Nagji has given the overview in totality for semicon, I would like to give the perspective from automotive point of view. Where the global market is, where the Indian market is, and where it is going to be, and how it is helping semiconductors to grow into the Indian and global market. In 2023, global market was producing 81 million units, which will be around 110 million by 2030. It means the revenue from 2.7 trillion will grow to $3.5 trillion. And if I come to India, in 2023, we produced around 22 million units. And I see the data suggests that by 2030, it will be 37 million units. with the CAGR of 7%. And the total revenue will grow from 100 billion to 300 billion US dollars. And particularly coming back to semiconductors into the automotive, global automotive semicon market was around 55 billion US dollars in 2022. And with the expected CAGR of 9.5 to 10%, it will grow to 105 billion US dollars by 2030. And so far, Indian automotive semicon market is just 1.5 billion US dollars. But against the growth of 7% in automotive sector, the semicons in automotive sector will grow by at least 30% for next 6-7 years. And by 2030, it will go to 10.5 billion US dollars. So so it gives a lot of opportunity here that although the automotive market is growing by 7%, but the penetration of semicons in automotive is growing by 30%. But most of this percentage is skewed towards the imports only at the moment. So it gives us a lot of opportunity to be in India. Since the automotive is growing, global automotive is growing, Indian automotive is growing, and penetration of semicons is growing even better in automotives. So it gives us a huge opportunity to be in India, to be in Gujarat, to invest in the semicon market. Thank you.
Thank you very much, Amit ji, for I think taking up nicely and brief. So I'll just add on this actually. With all this growth which we are talking, the current market size globally of semiconductor, which is $545 billion or $550 billion, is likely to be $1 trillion US dollar by 2030. And the major contribution is going to come from even healthcare. Is one of the largest in IT spend. As I talked to you earlier, it is around $5 trillion globally. And one of the major consumer is healthcare and agriculture. We have a very virgin area of defense, which was very closely guarded by government for years, and space technology. We have Nilesh Bhai, and they have come up with in space to promote the private players to embark on this journey. And government has taken a lot of initiative and a lot of facilities has been created. A lot of investment has gone into the equipment, testing facility, everything. I would like Nilesh Bhai to give some idea how this is going to help the local and Indian player to enter into this market using this in-space facility. Yeah. And what in-space has currently.
So in my first round, I mentioned about the space segment. Now, generally people believe that launching satellite means only space segment, but it has other two segments also directly associated with it. One is the ground segment. Once you launch a satellite, you need a very big ground infrastructure, which is almost 60 to 70% of what the investment goes into the space sector. So setting up of various earth stations and associated technologies. And the third one is the user segment, where you use the NAVIC receivers or ground terminals, VSAT terminals, all these things. So there is a huge potential for ground as well as user segment, and that is where in-space is going to play a major role, because the downstream activities, all of you know, is almost 70% compared to the space segment, which is 30%. Of course, right now, since it is the beginning of this opening of the space sector, so a lot of enthusiasm and excitement is there, and the startups which are coming up, they are more attracted towards launching, having launch vehicles or making satellites. But this excitement or this euphoria is going to die down. That's what I feel. The major market is going to be in the downstream, and that is where in-space is going to play a major role. And they've already started various incentive schemes. So government has already allowed 100% FDI for space sector related reforms under that. So in-space is setting up a seed fund, and there is going to be a very big announcement on, we are nearing the first anniversary of Chandrayaan-3 soft landing on 23rd August. And I would like to keep that excitement or suspense, because Prime Minister is going to announce many incentives on that particular day related to space sector and associated segments. So that is one thing which we are looking forward to. As far as in-space is concerned, as I mentioned, right now, as far as our captive foundry like SCL is concerned, and there is a GATEC foundry from DRDO, that both the foundries we are supporting, there is going to be a very good investment into these two foundries as well. And two major segments, that is navigation and quantum electronics. These are going to be the major areas where there is going to be a lot of investment and a lot of activities are going to happen in next 5 to 10 years related to these two fields. So InSpace, which is with its headquarters at Ahmedabad, is setting up various seed funds for various upstream as well as downstream activities. The small satellite launch vehicle, which ISRO has now almost qualified, and with 2 development flights already over and another 2 being planned in near future, it will be totally handed over to private sector, and it will be operated, built, as well as all activities will be done by private sector only. And the tender related to that is already out. Similarly, various other activities related to user and ground segment are also going to get a lot of attraction as well as funding from government sector. So a lot of incentives have been announced. They are going to be announced by InSpace. And so there is a lot of scope for newcomers into the space sector with this new space policy. Thank you.
Thank you, Nilesh bhai. And we have 1 minute and 17 seconds. So I will just try to make use of Tata because I think they are the major investor in the state and in the country. So I heard and I know that you have announced that the current plan is to go for manufacturing of 28 nanometer and beyond actually that. Do you have any plan in future to go to sub 10 nanometer? And why not? Or if yes, then why yes?
In fact, the government of India has plans to come down to 14 nanometer and begin with the R&D, starting with 28 nanometer, do R&D and start working with 14 nanometer. 14 nanometer has entirely different challenges compared to 28 nanometer. Technically speaking, the 14 nanometer is a FinFET technology, whereas 28 nanometer is MOSFET technology. The game entirely changes. The lithography at 14 nanometer entirely changes from 28 nanometer. The lithography equipment suppliers itself is very limited for that. But yes, the government has already started working on that, and in fact, they have announced a modernization plan for the R&D modernization plan, and in the last budget itself, there was a handsome amount sanctioned for that. There are quite a few organizations, including Tata's, working with the government to come out with the 14 nanometer technology plan. Yeah. Thank you.
So I think thanks all of you. I think we are running short of time. I may not be able to have the second question, but I have one request to make to Hero Corp, CG Power, and even to Tata. We are talking about building and designing houses, fabulous design house, like our company's last 30 years in the design house, but we don't have IP. Now, if they can list out, or if they can publish, what kind of IP will be needed in the chips which they are going to build in each area, like Tata can come up, then all startup or old companies which are in existence, having a lot of good talent, they can manufacture those IP, so it becomes billable. See, people build IP in isolation, and the revenue stream is not known. So if the revenue stream is known, then I think investment will make sense on those areas. So my humble request to all of you, if you can just come up with the small list, if it is confidential, please don't do that, but there will be a lot of ancillaries. There are a lot of versions coming in, because see, the basic IP is built, but then there is some modifications needed. So I think we can do those derivative IPs. At least we can handle it over here to start with before we become mature. Thank you once again, all of the panelists, and extremely sorry, not because of me, but because of the, I think, organizational people that we have to cut short on the second round. I will love to have 2 questions from the audience. If at all there is any question.
I think we have done a good job, so there are no questions.
No, there is one.
No, sir, there are 2.
Come forward.
You're loud enough. Let,
but the framework, the guideline is missing completely. Humble request that there is a youth who are looking for opportunities. If you can give a framework to this for all of us. Thank you so much.
so it's a good question. There is a separate session coming up later in the day on education itself. And just for FYI, today Gujarat Technology University has signed 2 MOU, one with Keynes and another is with the Suchi Semiconductor. I think both the people, our CEO and founders are here. As far as the syllabus, guidelines, everything, see, chip design and all those things are not new area. What we need is on the manufacturing and packaging side. And I think that is going to take a lot of attention and things. And I think government of Gujarat and government of India, all they are firmly aware about these things. And this is in the place, it will just roll out with the time.
In fact, I suggest that you look into SMDP program of Government of India. If you Google for Special Manpower Development Program, you will find lot of courses for VLSI chip design side and a lot of universities which have been supported by the government for this SMDP program. This is a Special Manpower Development Program of Government of India.
And there are 2 centers of excellence coming up. One is with IIT Gandhinagar and another is with the LD Engineering College at the cost of 3 crore rupees each. And Micron is supplying a lot of old equipments to train the people. Likewise, things will happen with the time. One more question. Hello? Yes?
Instrumental in terms of driving efficiency in the sector. Can some of the panelists highlight the role of AI in terms of how it's going to affect and what aspects of this whole industry will AI affect?
Are you talking about in terms of manufacturing side or on the design side?
Number 1 is yield and efficiency when it comes to manufacturing. These are the 2 areas which is focused by Synopsys primarily, and they are tied up with Tata.
On the design side, I think on the verification side, it is playing a major role. We have been writing hundreds of corner cases and test cases. Now those kind of a job, AI is going to do it automatically. There are certain risks about it, but I think with the time it will mature the model actually. On the layout side, once again, similar story. And as I think people say that there is a fear that whether will AI take over the jobs. But human has created AI and AI has not created human. So don't worry about losing the job. When the computers came, people are saying that we will lose the job in the bank and other areas, but job has multiplied. So AI is going to help to increase your efficiency and lowering the cost. Similar thing is going to happen even in environment because this is very environment sensitive production. And AI is going to play a major role in terms of, once again, efficiency and quality of the things. Actually. This is a separate session. We are, I think if possible, I mean, Gujarat in my company, we are going to get the Siemens guy to talk about how this AI
Yeah. Okay, we're running short of time because we have 4 presentations to go for.
It will take just a minute.
Okay, I hope the answer also comes in a minute. Yes, please.
So we know that the semiconductor market is an oligopoly, and companies like NVIDIA are buying out smaller companies who have a potential to compete with them. Then what should Indian startups do so that they could survive and thrive?
They get acquired. They should get acquired. Why do you want to do these things? If you take any sector in the world, Ultimately, it is going to be 3 to 4 companies, they are going to rule it. You take Amazon, you take Flipkart. This is how it is. You take telecom. How many players are there? How many players were, small players were there actually? Even government of Gujarat has funded a lot of players. Ultimately, they get acquired. But if you have an IP, nobody can buy you out. You can milk the cow lifetime. Build IP. Don't worry about acquisition. Thank you, sir.
Thank you very much, sir. And I now request Dr. Madhvi Joshi to do the honors of presenting the mementos. Joint Director, GBRC. And yes, the obedient crowd, what are you supposed to do again? Thank you so much. Ladies and gentlemen, we'll have a microchip break of only 10 minutes, and you'll have to come back over here for the next session, which is on efficient logistics of the semiconductor industry. Thank you very much for having you all here. Thank you very much, and I request all of you to kindly step forward for a group photo.
Yeah, we'll just take a group photo. Please come in the front.
Do we hold this in front of us?
Is Raghu sir in the room? No, I think he left.
Now there is no time constraint. Now there is no time.
Thank you very much once again, all the panelists and moderators, sir, for doing the wonderful job of an exciting panel discussion. Thank you.
એક જ પોઈન્ટ છે આ એક સિંગલ વાળું છે પૂર્વી સારી ચેર સીધર ને સારી સારી ચેર સારી ઉધર જાન દે